Hello, everybody, and welcome to another chapter and another video in our machine learning tutorial. And in this video, actually, in this chapter, we're gonna study some problems in machine learning and their solutions because machine learning is not perfect, but we can adapt to fit the data more properly. We're gonna see what are we talking about in a minute. So in this chapter, we're gonna take a look in on something called multi-class classification. Well, I promised you actually to last video. I promised you to see that situation, like when you want to classify more than just two classes. That means it's not like logistic regression. So what we can do about that, and one versus all. Actually, that's the solution for multi-class classification. Then we're going to see the problem of underfitting and overfitting with linear regression, and the same problem with logistic regression. So let's get started. First, multi-class classification. For example, when we have like an email, friends, family, work, advertisement, something like that, and we want to classify for multiple classes, not just two, not just like for example friends and family, but multiple. And in that situation, we're gonna have like y0, y1, y3, y4, and until yn. That means we don't have like 0 and 1 like we had in logistic regression, but much more than that. Another example is in medical diagnosis. For example, you want to have like depending on the features X, which is represented in like some the diagnosis of a doctor on the patient. For example, the patient has fever and so on, so on, so on. So as a result, we can conclude that he has a cold, or he has a flu, or he's not sick at all. Maybe he's just plain sick. So something like that. And that's also multiple classes, like y equals 0, y equals 1, and y equals 2. Let's elaborate more on this concept. So for example, our famously used example, the breast cancer, you can see here that we have only two classes. So no problem with that. But with multi-class classifications, we have this class, and this class. So it's 3 classes. This is just an example. There is many other example when we like have like 10 classes, 100 classes. So it's really hard to tell. So what's the solution for that? This solution called one versus all classification. How we can classify all these classes? We can use all versus one method. What do we mean by that? I told you in a minute ago that this, let's call this class 1, this class 2, and this is class 3. So what do? We train a classifier with a hypothesis function h of x. 1, you can see here the subscript 1, and train it to like classify class 1. If it's not class 1, just assign it to 0. Like that means here y equals 1, and the rest is y equals 0. So 1 versus everything else. And that's why we call this type of solution one versus all, because we take it class by class. So after training this hypothesis function, getting the parameters to define either this class 1, or if the element, if the input, if the features, I'm giving multiple names, multiple concepts, so you can distinguish. So if your input is from this class, it's the y equals 1. If not, y equals 0. And that's in this situation, it's obvious, because that's logistic regression, which we studied and practiced in previous videos. So it's easy for us to know how to do it. So as I said, we train a classifier, let's call it h1x. Then we train another classifier, h2 subscript 2x, which gonna assign if the variable, if the input is from this class, which is class 2, the y equals 1. If not, which is like class 1 or 3, the y gonna equal 0. And then we have a third classifier, h subscript 3 of x, that does the same thing just for class 3. That means if the input is from class 3, the y equals 1. If it's from class 1 or 2, the y equals 0. And that's how we can apply logistic regression to solve to solve a problem with multiple classes. So I hope it's actually easy. It's just like try to divide your data with the like it's kind of creating I heard like one data scientist call it like creating a fake data. If it is like this subclass, we call it 1. If not, we call it 0, and that's how we train just a logistic regression and get like really good results. So what did we just do? Again, we train a logistic regression classifier hi of x for each class I to predict the probability that y equals I. That means we're gonna like do all the logistic regression I times. That means the number of classes. As the example we saw, we have here 3 classes, 1, 2, and 3. So we're gonna have 3 classifiers, a classifier for each class, and we calculate the probability. So with every input x, we choose the class that maximizes hi of x. So we are calculating the probability that y, this is mathematically speaking, the probability of y is equal to I given x, w, and b. That's for each hi of x. So this is a one versus all classification. Next, another very like famous problem is called the overfitting and underfitting problems. So let's go back to the logistic linear regression example that we had in the first videos of this course. So you remember when we like tried to fit a linear classifier to our data of the house prices according to the size. We had like kind of it's pretty bad fit to the data, as you can see, because it's not like we said that it's like the best fit of our data is kind of quadratic function, and this is just a linear function, and you can see that it doesn't fit our data well. So this is called underfitting because it doesn't even fit the training data. This is the training data. And this is, we said this, the quadratic function is the best solution. And you can see, yes, it is the best solution because it fits the data pretty well. And now the problem is this. You can see here that the given function, because we are having like until the power of 4, x the power of 4, it fits the data exactly. So it fits the training data not just well, it fits like 100%. But imagine if we like have a new example, because the point of machine learning is to predict for new examples. Imagine if we have like new example here, like small example here. You can know that it's not gonna fit our data. It's not gonna give us the right value, this prediction, because it's totally out. So this is called overfitting. That means it overfits the data, the training data. And you remember in the previous video, the practical video I showed you, I told you how important it is to divide your data on two sets of data, the training set and the test set. So here, like, the training set is going to work really, really well, but the test set, if you remember last video, if you don't remember, just go back to last video in the practical video. The test set gonna fit like really, really bad, and this kind of fitting of the data is useless to us. So how do we solve this problem? In overfitting, the hypothesis function fits the training data very well, but do not work well for new examples, as I said, and this is called cannot generalize. So it's not able to generalize for new data. The red terms, because it's like the very important terms here. So we saw this case of underfitting and overfitting and on. These problems are we saw them in linear regression. Now let's see them with logistic regression. So as you can see here, with logistic regression, we have like a linear solution. You can see that the linear solution is good, but far from like really good, or you can say the best. It's totally far from that, because you can see here we have 3, 4, 5, like 5 instances of the training data are actually considered malignant. If we consider it as malignant and benign tumors, depending on age and size, you can imagine this age and size. You can see that these are not like really fit to the data, especially these 3. We can say that these are okay, but these 3 are very bad fit to the data because of these 3. So the best fit of the data of our data is probably the best, I think, is like this. So you can see here we actually divide. This is like the good the benign. There is no good tumor, but the benign tumors, and this is like the malignant tumors. So you can say that like it doesn't underfit and it doesn't overfit, so it's okay. While for overfitting, you can say here that it totally overfits the data, because there is a high chance, for example, that a malignant tumor can be here, and it's gonna be considered as a benign tumor, or the opposite. So it's really bad in terms of generalizing to new data. It's good for our training data, but really bad for test data or generalize to new data, given data, to predict a new output. So in this video, we presented the problems of overfitting and underfitting. Especially, we presented the problem if we have like multiple multi-class classification, how to deal with it with logistic regression. We presented a solution also, so we are done with that. And here also we solved the problem of overfitting and underfitting, but we didn't see the solution. The solution is next video, so stay tuned and see you next video. Thank you very much.